In this lesson, we'll pattern rotary position operations. After completing this lesson, you'll be able to create a toolpath pattern. In Fusion 360, we want to carry on with our 3+1 data set. At this point, we've created a 2D pocket and a 2D contour for our chamfered edge. We've done a drilling operation to spot drill, and tap the hole. Now we want to take all of these operations and we want to pattern them around so that way we create a separate instance of them at each location. We started with the first instance and we've got 2, 3, 4, 5, and 6 around the entire part. To get started, we're going to select 2D Pocket and shift select the last operation, selecting all of them. Then we'll go to Setup and create a new pattern. We're going to select the pattern type as a circular pattern. Then we need to select the axis. In this case, just a cylindrical edge. This will allow us to make sure that we're patterning around this circular part. Then we need to enter the number of instances that we have. In this case, it's going to be 6. Notice that we have some options for things like ordering. We can order by tool, by operation, and we can preserve the order. In this case, ordering by tool will mean that we're moving to each position, and then we're going to switch tools when we get back to the original position and work our way around. You have to consider the implications of this based on the size of your part and the speed at which this axis can turn. So if your tool changes are a lot faster than the rotational speed of your A-axis, it might make more sense to preserve the order and do everything how you programmed it. However, if the rotation is fairly quick, then it's better for you to go ahead and keep the same tool in the spindle and move around to each individual operation. Another thing you'll notice is that we have a lot of cutting moves, but we also have some rapid moves that are well above the part. We can tighten these up by changing the heights inside of our operations. But for our purposes, I'm going to leave them all as default as they are very safe positions. Next, I'm going to move to the Post-Process tab. There's an option here called Override WCS Offset. This will allow us to override the WCS offset in the setup, and we can use this for all toolpaths within this folder. So this is important to understand, and we'll talk a little bit more later on about WCS offsets and the WCS offset in a pattern. But essentially what this allows us to do is determine if we're using a new WCS for these patterned instances. In this case, we don't want to do that, so we're going to say OK. Once it calculates all these, we'll be able to see the results inside of this folder. So if I go down to the last drilling operation, you can see that it's drilling all of the holes. If we expand this, you'll notice that each of them underneath has the tool, information about the WCS, and the size of the toolpath. But one thing you'll notice is that it's not showing us each individual version of that. It's only showing us the original, and anytime we cycle through here, it's changing each position. If we were to go into a simulation, for example, for the entire pattern, if we play through or if we simply drag through, you can see that it's doing our pocket operation in each position. As it gets through all of those, it's going to move to our chamfer. Then it's going to go back and spot drill each position, and then drill and tap each one. It's important to note that when we're previewing this, what we're actually seeing is the tool move around the part. But in reality, the tool is not moving in relation to the part. It's staying fixed in its spindle, and the part is rotating to each position. So it's important to understand the distinction between the difference when we're simulating this and what the actual motion is on our machine. From here, now that we have all the pattern instances, I want to make sure that I save this before moving on to the next step.